Welcome back. This is the sixth video for 1998 AP Calculus AB exam. The first 5 videos covered all of the multiple choice, section 1, part A and B, the section without the calculator and the section with the calculator. Now we are going to do videos that cover one problem at a time. We are going to cover section 2. Notice there is no section 2A and section 2B in 1998. All right, 24 years ago. It's crazy. But one thing is you get a graphing calculator for the entire section for all 6 problems. This made up 50% of your grade back then. I'm not even sure. It might be the same now or a little bit less. But keep in mind that this was 24 years ago, and you would have gotten an hour and a half to do these 6 problems back in the day. So let's go ahead and do this, and we will move forward. 1, let R be the region bounded by the x-axis, the graph of the square root of y, and the line x equals 4. Okay, so I like to sketch, when possible, little things here. So we'll talk about A here. 1, 2, 3, 4. Yep, 4. All right. 1, 2, 3. Here's your 0. Here's your 0 on the y. 1, 2. That's fantastic. All right. Put some dots here. We got a dot here. 1, 1. 4. The square root of 4 is 2. Y equals the square root of x. Y. Now, they want us between the x-axis, which is this bad boy right here, the line x equals 4 right here, and my graph of the square root of y. You can see here, we are going to find the area of this part right here. All right? And we're going to do that. Area under the curve is integration. So the first thing I'm going to do is I'm going to integrate. All right, let's go down here. I'm going to integrate from 0 to 4 the square root of x dx. All right? Now, the first thing I'm going to do, and what I tell my students is, I'm going to change that square root to an exponent. A square root is the same as an exponent of 1/2. If you didn't know that or you forgot that, that's important to be able to convert. When it comes to derivatives and integrals, exponents are key. All right? Let's not forget our dx. Now, you might say to yourself, well, Visca, I have a calculator. Can't I just put this in there? I mean, probably, but at some point you're going to have to integrate simple stuff like this. And guess what? It's not 1998. So we're going to do the simple work still by hand. We will check with the calculator. All right? If I integrate this, okay, that's x. I add 1 to my exponent, so it becomes 3/2. And I divide by 3/2. What I tell my students get used to, when you divide by a fraction, you multiply by the reciprocal. So instead of dividing by 3 over 2, we're multiplying by 2 over 3. And I want this from 0 to 4. Okay? So let's put in our 4. So it's 2 times 4 to the 3/2 over 3 minus, let's throw in a 0. Love me some zeros for calculating, not for my grade book. Okay? Anything times 0 goes bye-bye. Gone. Let's just figure out what this is. All right. Okay, by the way, this is the root. The top is the exponent. So the square root of 4 is 2. 2 cubed is 8. So I've got 2 times 8 over 3. And if I do my math there, I get 16/3, which is approximately 5.333. Okay? So the area is 16/3. The area of this whole thing is 16/3. That's the area of all that yellow highlighting. Now, if we wanted to check this, because we have the calculator, let's certainly go right here, turn this on, go to Math 9, from 0 to 4. It's the square root of x. Don't forget the dummy variable, dx. Boom. And there it is, 5.333. All right, good to go. 1 is done, or 1a, I should say, is done. So let's bring this up here, and we're now going to do B. We're going to do it in purple. How about that? How about that? Bam. B. So B states, find the value of h such that the vertical line x equals h divides that region R into 2 regions of equal area. So I'm going to pick some number, I don't know, I guess between 2 and 3 probably. I don't know what it is, where x equals h. Where each half, okay, of this area, it actually equals half of the area. Meaning, if the total area is 16 over 3, each one of these should be 8 over 3. Okay? Now, I can pick one of 2 options. I can integrate from 0 to h, and that should equal this 8/3. Or I can go from h to 4, and it should equal this 8/3. I'm going to pick 0 to h. How come? I love when I put zeros into my integrals, because what happens? Zeros make things go bye-bye. All right? So I'm going to integrate from 0 to h. I don't know what h is, but I know when I integrate my function from 0 to h, it should be 8/3. All right? So I've already done this integral. That's 2/3 x to the 3/2 equals, from 0 to h. That should equal 8/3. All right, let's do some math. 2/3 h to the 3/2 minus 2/3 times 0 to the 3/2 should equal 8/3. Anything times 0, bye-bye. That's why I love it, my friends. So when everything's all said and done, I have 2/3 h to 3/2 equals 8/3. If you know anything about fractions, you know that if all the fractions in the bottom are the same, they go bye-bye. So now I've got 2h to the 3/2 equals 8. All right? And I'm just going to use, algebra to solve for this thing. It's really, really easy. How about we do this? How about we multiply both sides by 1/2, or divided by 2, I should say. So now I've got h to the 3/2 equals 4. All right, okay, cool that. How do I get rid of the 3/2? I raise it to the reciprocal, 2/3. You should know that. Absolutely. All right, this goes bye-bye. And I've got h is equal to the cubed root of 4 squared. I mean, I could leave this as an answer, but we have the calculator, so let's do that. And we got, that's the cubed root of 16. And let's figure out what that is. We said it should be between 2 and 3. I mean, it looks like it should be there. So I will say the cubed root, oh, that's square root, clear. Math 4. The cubed root of 16 is 2.520, okay? This 19 will round up to 20 because the number after it is 5 or bigger. So 2.520. So h, let's get a little bit more room here. H equals 2.520. We are good to go there. Boom. Let's get rid of this. And All right, good. 1a is done, and then we used a to do b because we had half of the area in a. Okay, it's good. Looks good. Looks like good math. I think so. I hope so. God, I hope so. Boom, boom. Let's go this mint green. I like it for C. C. Find the volume of the solid generated when R is revolved about the x-axis. Oh, I love volume ones. Okay, so for poops and giggles, we have our graph here. 1, 2, 3, 4. Okay, and it goes 1, 1, 2, 4. It goes like this, something like that. That's a square root of x. Okay, they want it still from 0 to 4, from 0 to 4. But this time, my graph is going to be rotated around the x-axis. So it's actually going to spin around the x-axis, which means it's going to make a circle. Okay? And any time we want the volume, we integrate the area. The area of a circle is pi r squared. What's my radius in this case? Whatever's here, it's the square root of x. This line represents my radius. If it's right here, boom, the radius is the square root of whatever x is. Right here, boom, it's a square root of whatever this x is. Right here, boom, it's a square root of whatever x this is. So it's always the square root of x. Pi times the square root of x squared. I've got to integrate that. All right? So let's integrate. Pi is a constant. I'm going to move this on the outside. 0 to 4 are some of my bounds of the radius squared dx. Now, beautiful thing here, squares and square roots cancel. So I'm really just finding the integral of x. Ooh, that's x squared over 2. I want that from 0 to 4. Love me them zeros. And oh, by the way, let's not forget, we still got to multiply that times my pi on the outside. All right? Let's keep on trucking. We're doing good. We're doing good. So I've got pi times 4 squared over 2 minus 0 squared over 2. Love it. Zeros go away. And I get pi times 16 over 2, which is just 8 pi. That's fine. The volume is 8 pi. Done. That wasn't too bad. That wasn't too bad at all. So we got a lot of this good work here. This is good work. All right? So we got our answer to C. And last but not least, we need to do the last one, option D. Okay? The vertical line x equals k. That looks a lot like B, where there's a vertical line x equals h. But let's continue reading this. Okay? The vertical line x equals k divides the region R into 2 regions such that these 2 regions are revolved around the x-axis. They generate solids with equal volumes. Find k. So I am taking my volume here, okay? All of these circles here that create this volume. I'm actually going to do the same thing I did in B, where I cut the area in half. But this time, what would really pop off that? Blue. I want to find some value k. Okay, whatever x value is there, that would cut my volume in half. Again, if the total volume is 8 pi for everything, when I take half of that, that means this side should be 4 pi, and this side should be 4 pi. I don't know if you can see that yellow really good, but those are 4 pi's. Oh, would black pop better? 4 pi on this area, and 4 pi on that area. Okay, so now I can take, from 0 to k and integrate it and make it equal to 4 pi. That's my k. Or from k to 4. I'm going to use 0 to k because I like using bounds. Okay, the lower bound and upper bound that are 0. So I'm going to integrate from 0 to k, and it should equal 4 pi. Okay, so D. If I integrate from 0 to k, remember, it's the integration of the area as volume. It is pi r squared. My r is the square root of x squared dx. Okay? That should equal 4 pi. All right? Should equal 4 pi. So let's go. Well, here we go again. We've already did this. This is x squared over 2 from 0 to k. By the way, the pi comes out front, and it should equal 4 pi. First thing that jumps out to me, let's get rid of the pi's. If we divide both sides by pi's, these go bye-bye. Let's put our k into x first. K squared over 2 minus, putting in our lower bound, 0 squared over 2. Goodness, this happens almost every problem on 1, and I love it. It should equal 4. So now I've got k squared over 2 equals 4. I don't know. Let's multiply both sides by 2. So we got k squared equals 8. All right, well, one last thing. Square root both sides. K equals the square root of 8. All right? And the square root of 8, if I put that in a calculator, and let's make sure, I mean, I could reduce that with radicals or whatever, but they never ask you to simplify on part 2s, okay? So I'm going to just take the square root of 8 and get 2.828, which is approximately 2.828. There you go. That's the answer. If I look up here, I mean, somewhere, I mean, this is actually closer to 3 than it is 2, 2.828. It's good. It's good. We're all done. You know what? I'm helping you out here, so why don't you do me a favor, help me out, and ring that bell and like these videos. Follow me on YouTube so you will get a notification when I put up problem 2, the video for problem 3, the video for problem 4, and so forth. And like I mentioned last video, you know what? Buy Blink-182's album, Enema of the State. It will change your life. God, I love punk pop. I love punk pop. It's my favorite. I like all music, but that one just hits home. You know what I'm saying? Enema of the State. Buy it. I'll see you guys for the next video. Bye-bye.